All, is my video visible?
Yes,
Yes, sir.
yes, sir.
Great. Sorry, I'm not in formals today as it is officially holiday. Okay, so let's start with our next session. Uh, so in this session, we will be taking some demonstration. So first demonstration will say we'll take about cloud and our devices. So here is a quick circuit. So I'm having DHT11 sensor. We will be printing out current temperature and humidity on a cloud. And for connecting this on a cloud, we are using Node MCU with ESP8266 as a chipset. So what we will be doing here is we'll first interface the sensor as I have already wired it to save our wiring time. So what I've given is the sensor I have put it to a 5 volt, that is a VIN pin, and ground to the ground, and one is the out, which is a sensor pin which I have plugged to D4 of the node MCU. Now for taking the whatever the sensor is reading on a cloud and printing it, for this we will be using analog cloud, as this is the analog sensor, and we can get the analog data out, and we can limit this data as a data set, like we can have a bar chart or a panel graph or something. So for this what we can do is we can use ThinkSpeak cloud, as this is again a free cloud where we can get but having a very limited usability. Then after that we'll get another demonstration of servo motors. We can create application on a cloud which from where we can control our servo motor and servo motors rotation. So this is a 180-degree servo motor, so we can control the entire rotation of the servo motors. Like I'm doing it manually over here, we can do it through our cloud application. So that application will have one of the a switch, or we can say a slider switch, which we will be using to control our instrument. Illustrating that we are controlling a movable instrument, so we can this thing we can implement in the field. Like if you wanted to turn on or turn off our machinery, we can do it from a cloud. Or in agricultural field, if we wanted to turn on and turn off pumps, water pumps, or any other electrical appliances, we can do it from the cloud. Or else whatever we wanted to control, even we wanted to control our rover, we wanted to control our quadcopter, so everything we can control it through cloud. So by sitting here at my place, I can control it anywhere in the world. So that ability we can get. So for that we will be using another cloud service which is given us by adafruit. So adafruit is a big company which produces some sensors, modules, actuators, and even they are having their sensor libraries. Even they are having their IO libraries, which can be worked in Arduino Uno, or which can be worked in Arduino IDE as well. But as I'm again controlling this through web or from internet actually, not from the web. So for that we need to connect it with our router, and again I'll be using another node MCU with me. I can use only ESP8266, but I need to interface it separately with Arduino, any development board, Uno, Nano, or Mega, or Micro Mini, or Micro Mini Pro, and and maybe there can be a loss in communication. So that's why I'm using ESP8266, which is embedded on a node MCU. So that is in a better sense. So let's have a look at the ThinkSpeak first. So I'll just share my screen and I'll unpin my video. Okay. So to create an account on ThinkSpeak, we need to go thinkspeak.com, and you can click on get started for a free. Just fill up a registration form, your Gmail account or something, and you can have account ready. And the illustration what you are seeing on this tab, exactly the illustration we can get where we are going to work. So, but ThingSpeak is very limited with these kind of a bar or graph or these kind of a charts, line charts. It will not give us a functionality like we can control our device from some kind of a instrument. That functionality ThingSpeak is not giving. But it is a very good source for collecting a data from sensor and creating some kind of a data set where we can use in further application. So here I am already registered with ThingSpeak. Let me log in into it. Oh, password is correct. Oh, okay. Now the ThingSpeak is a very good example of data aggregation, as this ThingSpeak is having preferred channels, or we can create preferred channels, and we can associate our ThingSpeak with various development boards, and we can associate it with the various sensors, and we can get the data accumulated over the channels. And even we are having a functionality like we can open that channel for public use, or we can open that channel for only private use or private view. So that functionality also we can get. So this is a dashboard of ThingSpeak. Now here, as we can see, I have two channels. One is a test one, another is a weather station. So what I'll be doing is I have already created a channel, but we can get unlimited channels to create, as there is no costing for it. Or rather than if you need a faster data speed, because once we are on a free channel, then it requires at least a 15-second of a delay. So 15 seconds of a delay it will require to collect another chunk of a data. So accordingly we need to set a delay in our programming. But if we want a real time data, then we can subscribe for the ThingSpeak and we can get a real time data without having any delay. But this is not the case in Adafruit IO. So Adafruit IO will give us a complete real time application, but they are having a limitation on what channel you can create. You can create only 10 channels, you can create only 10 streams. So that is the free version what we can get. But for a beginner, or we can say for a practice, not actually a beginner but for a practice, this is well enough for us. So what I'll do is I'll first create a channel. Now the question will come, what exactly channel is. So channel is your viewing area or your mid application. So thus ThingSpeak is entirely a dashboard, and the channels will be act as a application. So here if you can see test one and weather station, these are two my channels which I have created. So once I'm clicking on the channel, I'm creating a new application for me. But ThingSpeak is not giving me opportunity to manage my channel, or I cannot go beyond the syntax or beyond the boundaries what ThingSpeak have set it for me. But this is not the case of AWS cloud or Azure cloud. In that we can create our own cloud environment where we can host our own application. Even whatever the application we have deployed or created for collecting information and everything, that we can deploy on a AWS cloud source. And through that, AWS IoT and IoT cloud can control the devices or can control the use and the data of what that device is collecting or that device is required. So start with the very not the basic but the intermediate one, because again ThingSpeak is not a basic cloud, it is an intermediate cloud. So let's click on a new channel to create our app. So here we need to give a proper name so you can identify it. So here I'm taking up DHT11 test. Then you can give description if you want. I'm just leaving it as it is. Now here are the fields. Now what is a field? Field means how many graphs you want, or this application will generate what kind of a data. So in our application, DHT11 will generate temperature data and humidity data. So one graph will show us a temperature data and another graph will show us humidity data. So here one field means a graph. So one field is auto selected. There you can select another one, up to 8 fields you can select. And other information if you want, then you can give it here. Now channel settings and what they mean is already written over here at the help section. So it is having a very good documentation in terms of a beginner to use it. So you can go ahead and read it for a better understanding further when you are trying it by your end. And though if you stuck somewhere, you know where to reach me. You can reach me on the WhatsApp group, or even after a session I'll be leaving my contact details, so you can definitely reach me anytime. So here at the first field, I'll type temperature. I'll enable this. On the second field, I'll type humidity. I'll enable this. Now, I really don't require other fields to enable because my program, which I have already created, that program is only emitting two values. One is the temperature and another one is humidity. So it is a west of our field that we can enable, and we are just seeing a empty fields. Even the metadata is information about what you are collecting the information, so you can give your metadata or you can give your tags, so it is required for SEO as well. And furthermore, if you wanted to take the input of ThingSpeak collected data set or whatever the data you are having. And the beauty of ThingSpeak is once you created a channel, until unless you delete it, it will remain there on their server. So if you have your data on inserted on it, it will list long there, and whenever you wish to collect that data, you can collect it into a JSON file, XML file, even into a CSV. You can download it, or else you can have a API there. They will be giving you a API, or we will see how to create a API, and that API we can use to directly connect to the stream, and we can fetch that data into another application. So that functionality it is giving. That's why ThingSpeak is not a entry level or beginner kind of a cloud. It is what the intermediate cloud, and it is not that expert cloud as well. So I'm leaving these fields blank because I really don't require it right now. Now if you wanted to limit our channel, means the application, to be available in a certain location, then you can check this box, show channel location, and then you can give latitude and longitude, means the coordinates, GPS coordinates, and then your channel will be visible in that area only. But I want it to be in every area, so I'll just uncheck it. Even if you wanted to show video, then you can have a video over here and you can stream it on a video URL. And if you wanted to show the status, you can click on the show status. Now I'll click on the show status, and then I'll save it. So once I save it, so my application is created. Name is here DHT11 test, having a unique channel ID. So the question what we answered in first session, so how we can identify which channel or which sensor we have attached to. So like this, we are having a unique channel ID, and this channel is unique, or the channel ID is unique on entire ThingSpeak cloud. So it is not just for us, it is on to all the, and then we are having author. So if we click on the author, you can see all the channels what I have created. So this is my author page. I have not given my every information over here, so you will be not getting anything. But still, if I wanted to use this commercially, then I may feel all the information, so my profile will get created over here. But okay. Now the access level, if you can see, it is a private access level. Means what? Whatever the charts you are seeing over here, field 1 chart, field 2 chart, so these charts will be available only when I log in into ThingSpeak. But if I wanted to view this chart without logging it and publicly, then I need to make this public. So here it is a public view. To make this channel public, navigate to sharing, and if I click on the sharing, then here I can make the change. Keep channel view public. You can share it with the everyone, or you can share with the following users only. So I need to add email IDs and I need to add the users, so I can share with them only. So these are the facilities what I can get, as this is a collaborative effort, as I am mentioning it every time. So one's work can be my feed, and my work can be another's feed. So that can be possible. So there we can use the sharing option. Now here is a channel what we have created, and this is the empty channel, which is a channel status update. The status, I have clicked on the checkbox, so it will show us a status. So I don't know really what it will show us on a status update, but let's find it out once we are getting a data on this. So here it is, DHT11 test as my what we can say, uh, channel name. Then you can see temperature and humidity over here, then there's the date. So what it will generally do is it will show temperature day wise, and it will show humidity day wise, right? And even it will show it with the time interval. Then public view we just saw. Channel settings, here is the same channel setting what we see when we clicked on the new channel. Here you can make changes if you want, and if you wanted to add more fields, you can add more fields over here, right? Then sharing we see. Then most important part here is API keys. Now these are the API key which is required. So this is the right API. So now we'll require the right API to insert into our program. Why? Because whatever my sensor is going to sense, or whatever the DHT11 is going to sense, that needs to be right on the view over here. So on the chart that needs to be written. So that's why we can use a write key. And if you wanted to take out some information from channel and wanted to print it somewhere else, then you can use read APIs. So either you can directly take this API key, or you can click on generate new API key. Every time it can generate a new one for a better security. So this is the API key what is generated right now, and even this is a read API key which is generating. So you can use this, and read API you can use. So you can use directly these keys, or if you want, then you can use get method feed channels. So this is most appropriate when we are using any data visualizer tool where we wanted to add some APIs, or we wanted to create an application which will work on a mobile phone, and there we wanted to see our things only. Then we can use these APIs. So if we are having our own custom built application, we don't want to log in into a ThinkSpeak. So we can use these APIs to get data. Right. Now these APIs are again what we can say unique for DHT11 test and this channel only. So whatever the data this channel is presenting, that will be visible through these APIs. So once I generate a new API, automatically it is getting updated here as well. See, so the API is changed, A6PQ. Even here it is updated A6PQ. If I regenerate this again, now here also you can see write key is U4. Now the write key is U4. Read API is not getting changed. What I can do is I can delete the API from here, and now I can add new read API. So here we can directly generate, but for reading I need to delete it, and then I need to add it, or I can add one more read API key, because this is just to read the data. So I can use multiple read API keys for the multiple uh, applications if I'm having. And if we wanted to upload some kind of a data on our ThinkSpeak cloud, then we can upload it. CSV file is what we can say supported over here. So if you wanted to add some data, then you can download this format, and in this format you can upload the data. So this is typically done when we are having a data set to pass to our machine learning algorithm for doing the analysis. So that time we can have a data inserted on the ThinkSpeak, and then directly we can call it through API. Okay, so let's start. Let's get started on the DHT11. Let's interface it with the actual Node MCU, and let's see whether we will be able to capture the data on our fields or not. So for this, I'll be taking up my power cable. I'll just attach it. Now this is the code what I'll be using for ThinkSpeak. Code is same as DHT what we used for Arduino Uno, just a little modification, which includes ESP8266 Wi-Fi library. Then I have defined string as an API key, and here I am putting up my write API. So what I need to do is I need to copy the write API from here. If I go ahead and burn this in my node MCU, it will not show any kind of information. So I'll go to a API key. I'll check the write API, and then I'll paste it over here. uh, don't delete these codes, it needs to be as it is. Then of course a similar way, SSID and password, so NodeMCU will get connected to my existing router. So a NodeMCU will be in station mode. Then I have inserted a server. This is the API server link, api.thingspeak.com. This needs to be as it is. Then this is the same what we used in DHT11. So here I'm pinning it to a DHT pin to a D3 of Node MCU. Similarly, it is connecting to Wi-Fi. It will show once it is connected, it will show Wi-Fi connected IP address, and then it will go to ThinkSpeak on a server 80 for updating the information. So what kind of a update it will do? It will update with the X, means the my first character, that is the temperature, with the API key, and then another temperature. So this is the temperature and this is the humidity what it is going to uh, emit. And the same thing it will show us on a serial monitor. Once our information is updated on a ThinkSpeak, it will show us like humidity in percent is already degree Celsius, temperature degree Celsius, and humidity in percent, and it is already sent to ThinkSpeak. Now it will wait, as it is a client stop, it means that it will wait for 10,000 milliseconds a delay, and then automatically it will insert a new feed. As I said before, ThinkSpeak require a minimum of 15 seconds a delay between updates, but here I have set it for a 30 seconds. Now we are ready to go. Let me power the node MCU and let's run the code. I will select our port. Oh, my cable is faulty. I'm having another cable. So here we are having COM4. We'll just upload a new code. Code is a previous code only, old code only. Only the new thing we have added, that is the API key. So that we updated. That's why we are again uploading the code. Okay. So now it's being uploaded. We'll wait for at least 60 seconds. Once it is done, we'll open up our serial monitor to see the status. And once it is connected, it will start transmitting. Now I'll open up my serial monitor. Now if you can see over here, failed to read from DHT sensor. Maybe something is wrong with this. I put it on 3. Now here it can go. Yeah, now it is reading. uh, I made a mistake. I Instead of D3, I've connected it to a D4. That's why. Now if you can see over here, temperature 30 degree or 40 Celsius is recorded. Humidity is 31% and sent to ThinkSpeak. Once we get sent to ThinkSpeak or this message and it is waiting, it means that it have already forwarded our information here on our channel. So if everything is perfect, then we can see some graph. So here we can have a graph. Here is the data what we have got. So on this timestamp, temperature was 30. Timestamp is Saturday, March 6/21, and then it is rising. It is having 30. Then it is rising up on here. It is 30.4. So now it is 30.6. If you can see, it is a perfect triangle you can see over here, but still it is humidity is 31, peak was 34, now it is down to 31 again. And in each 30 seconds a delay, it will update itself. And on the channel update status, it will not show anything right now. Now here again, the drop in temperature is observed, and the same is observed over here as well. 30 seconds, if you can see 30.5, it is 30.6. Now these needs to be updated. Now this can be a 30.6. So this is a real-time data what we are dealing with, or we are uploading it. So interfacing our device with the ThinkSpeak kind of a cloud is not that hard. Just we need to do some a little modification in our code, and we can start recording our data. Now let's imagine if I put this continuously on my work area, and if I wanted to collect a data set out of it, ki, in a particularly in 30 days a cycle, what kind of a temperature drop and rise, or we can say fluctuation in temperature I have observed, then I'll be having this data set ready. And though in this demonstration I have not properly formatted this field, so maybe I need to work around a little bit to create some labels and everything, so that data can be look good, and we can use it as a data set. Even if you are using a data set in the MATLAB for creating a machine learning simulation, then what you can do is you can directly have MATLAB integration over here at the MATLAB analysis and MATLAB visualization. So there you can directly go. Or even if I wanted to download the data, then I can go to import and export. I'll select my time zone, that is 5:30 here, New Delhi, Mumbai. I need to select. Now why I need to select a time zone? So accordingly it will take the time as it is showing here. Accordingly it will take the time. Otherwise it will take time of that time zone what I've selected, UTC. Now here it is, by 5:30, which is near to me, and I'll open the feeds. So this is the data what we can get. So this is a ready-made feed. All right, create at the timestamp, entry ID, field 1, field 2, and the field what you are having. So here you can rename it after that, as this is a data cleansing technique in machine learning. And latitude, longitude, elevation, status. So depending upon that, depending upon the fields, it will get the information ready, and your data set is ready, and you can have your application on that. Right. So any question, any doubt using ThinkSpeak? It is a very straightforward and a very easy kind of a cloud to operate. Now, if I wanted to add some visualizers, so I can add it from here. So it is not giving me, as it needs to be in a uh, paid version, but I can add some widgets. So here is a gauge mark. Then we can have a numerical display. I can have a lamp detector. So let's take a gauge. If I put the gauge, then on the gauge I need to have the parameters. So name is temperature, so I can associate it with any of the field. So here I can select, so first field or a second field, so I'll update it with the first field. So this is the minimum percent, and this is the maximum one. And the unit, I can have measurement units, so I'll leave it as it is, or I can see degree. Okay. And the tick interval is 10 seconds, and update interval is 15 seconds. Range is 90 to 100, or I can add some other ranges as well. Once I click on this, now my degree is updated, and now it have taken up a 30.31.1 degree is the temperature right now. So if you wanted to have a good visualizer, then you can have it like this. So that is working pretty well. Even after a 15-second, this gauge is also changing. So here, but gauge is not appropriate over here, as we cannot show our temperature in a gauge. It is mostly in a graph or a line chart like this. When we will be requiring this visit, when we wanted to show any pressure or wind speed or flow speed, water flowing somewhere and some petrol or something. So whatever the flow we are having, pressure we are having, that we can show you. And 100 is the maximum one. That's why it is showing into a red. That also we can customize. We can click on edit over here, and we can have the color, which color you wanted to have as a danger one. So instead of range to 90 to 100, I'll put the range from 50 to 100, and I'll put OK on it. So it is taking up that. Depend, even I can customize, like if I want from 0 to 30, it is 30, it is normal. If I customize it a bit, so I'm getting proper one, and then I'll add 30 to 55 as OK. I means the it has started warning you that something is going wrong. I'll make it orange color. So now it is looks like a perfect gauge meter, right? After 15 seconds, it will update. So this is the about things speak. Now I've disconnected my node MCU. Now let me take you on adafruit. So this is the adafruit. You can visit adafruit io.adafruit.com. Then you can register. If I can see on the my profile, if I go on home, then we can see a current plan is I'm having 30 data points per minute. I'm having 30 days of a data storage. I'm having 15 minutes a trigger every. Trigger means what? If I wanted to get information frequently, and if I wanted to trigger something from my end, like that, whatever the collected information is, I need to forward it to other application. Then it is every 15 minutes. Then 10 feeds means what? Like we have here, this is a field. So here it is feed. So this is a field, and here it is a feed. That's the only difference. So here we are having 8 fields. 8 fields. Here we are having 10 fields. Then 5 dashboard we can create. Here we can create number of channels. There is no restriction on it, but here a restriction of that we can create only 5 channels, or we can upgrade it to get it with the extra plans. So here I'm leaving it as it is. Now here also will require key, but in a my key, if you can see, this is the only activation key. So here they will be not requiring any create or means the write or a read key. Only they required username and activation key. So it is totally different than the things speak, but it is giving us the ability to control our sensors or to control our devices. So let's see how we can control our servo motor through adafruit. So for this, what I'm doing is I've already created a field. Here it is, my field called servo. If this is the dashboard entry of my servo field, uh, I'm having it here. I'll go to a dashboard first, view all, and I'm having a servo dashboard over here. What I'll do is I'll create a new dashboard for you. I'll rename it as a servo dash, and I'll create it. I'll go to a servo dash. Here I need to create a widget. So which widget I'll be requiring? So I'll be using a slider bar. So here I'll be clicking on a new block. So here they rename it the widget as a block. So what block we can get? We can get a toggle switch, we'll get a button, we'll get a slider, we'll get a gauge where we can manage, we'll get a text, we'll get a stream, we'll get an image, live chart, icon, remote control, map, color picker, indicator, numpad, multi-line text, and dashboard links. So these different elements we can get. So right now we'll do with the slider. So once we click on a slider, it'll ask me which feed you wanted to have the slider. So here I have already created a servo feed. So I'll select this servo feed, click on next. So this is the slider what we can get. So this is just a preview. So I have set it to 100 degree, or this is a 100 max, but my servo is of 180 degree. So what I'll do is I'll block the title as servo counter, or I'll do like a servo only. Minimum value is 0, maximum value will be 180 degree. Slider step size, so you can define so how many step it can do. 10, that's 10 at a time. I can define it as a 5. Once I do it as a 5, so it can have like 5, 15, 25, 30, like this. Even if you wanted to give a slider as a label, then you can give as a label. I'll give it as a servo. Here you can have the label, but it is again not looking good, so I'll move it like degree. How can I get a degree over here? Okay, fine. Decimal places. Then I'll click on create a block. So once I create a block, here is the block which is created. Now you can see timestamp March 6th 21, and this is the time, and I move it to a 180 degree. Accordingly it will pitch it. So here at the my key, I'll be requiring this key to insert in my code. So I'm having a code over here. Now what I'm doing is I'm not using my own code. Instead of this, I'm using a simple example what Adafruit IO libraries is having. So I have already inserted Adafruit IO library, and from the example of it, so here if you can see, here is Adafruit IO Arduino. These are the different examples I can start with. So there is a temperature, oh sorry, here is a even there is a here humidity and temperature example, but that I have already shown you with the thing speak. So I thought I'll take it with the servo. So here the little changes we need to do on the configuration part. We need to provide our information, like here it is IO username. So here is the username, Tambe. Then we need to place our IO key. So this is the IO key what I am having, or I can regenerate the IO key. I'll paste it over here. Then here I need to give user ID and password. So RX100 is my username and password will be, yes, rest thing as it is, as I'm using node MCU, so I'm not or uncommenting this. I'm using a node MCU, so as it is. Then I'll come to the servo, I'll check out the servo pin over here, and then feed is servo feed. Okay, everything is set. My node MCU needs to be connected. So here is my servo is connected to D2 of node MCU. Here it is D2. I've given a servo as a 5 volt in, connecting to VIN, and one is the ground. Now what I have done is, let me I'll just pin my camera. Now to see the movement of servo, I have attached one gear, one panel gear. So once I'm changing rotation, it will change it somewhere. Like now it is stuck as it is stuck as it is on the final movement position. So I need to change it through my app. Now here I'll be uploading the configuration. It's compiling, it will take a while. Like previous example, it will show us connected to adafruit. So once it is connected to adafruit is displayed, then we can move our screen to adafruit controller over here, that what we have created as a servo, and then we can control our servo motor through the slider. Now I think my connection is done. If I go to, now it is saying that adafruit IO connected. Now I'm moving it. Once I'm moving it, you can probably see the movements. So it is now on 180 degree, it is on 0. Now again it is 180 degree, again it is 0. It is on 125, 80, 150, 0, and continuously back and forth we can control. Now if you can see, I'm on adafruit.com, so I'm totally on the cloud, and through cloud we can control any device like here. So this is the beauty of data aggregation. So here is the perfect example of data aggregation. Even I can control it speedy. Right. So all right then. So this is about the cloud connections and how we can get our devices on the cloud. So any questions, any doubt, any queries, or you wanted to add anything in this? Okay. So I guess there are no questions. Thank you. Now let's move to our next sessions part, that is security over the cloud. So I'll be not talking about much in detail about how we can get a security on the cloud, how we can get a security on the IoT or something. But rather than, what I can do is I can take you with the IoT security point, and we can discuss about that. So what kind of a security vulnerabilities will be there, and what we need to uh, consider. Like we already seen these kind of a secure these kind of a devices which can emit very valuable information. Like if we are having a router, then we can emit all data sent through the router, login information, email, web surfing data, lot and more, as we can pass through that router. Even if we are having a smart TV, smart watches, internet connected car, so all these kind of a instrument what we use in our daily life, which is directly connected to our network, will what we can say, emit some important information. Now if all these devices are emitting this information, then what kind of vulnerabilities will be there? So these are the security vulnerabilities what we usually see in all these types of devices. First one is insecure default login credentials. Means we just discussed it in our earlier session, that whatever the device we are having a configuration page for it. So we are leaving it as it is. So we are leaving that device configuration as it is, or the username and password as it is, thinking like who will be going to use it. But this is again a catastrophic event or a critical vulnerability in terms of if it is into hands of the wrong person, then the entire configuration of the router may get changed, and you will be end up with the loss of your information. And poor software updates, definitely these devices needs to be updated regularly. If we are failed to update these devices regularly, then uh, unupdated version is there, or old or outdated version is there. Because of that, some vulnerabilities can be triggered and that device can be hijacked. Then some devices may have a user interface, so that user interface is not coded properly, or username and password is not sanitized properly. Lack of encryption mechanism, lack of secure transmission protocol what we use. In a normal way we can use https or ssl, that is not being used. So there are different types of a reason where our user interface may be vulnerable. Then most of the time the reason is communication is not encrypted, so we fail to have a proper encryption mechanism, we fail to have some cryptographical solution on it. Because of that, our communication is not encrypted, and attacker can get onto our network and can steal some valuable information. Then of course there is a poor privacy protection. So if we are having an application like adafruit we just saw, like that, if we have created a own customized application to control some other application like your cctv camera, drone, or your vehicle, or any of the device where it is getting connected on the network, and that particular application is not properly signed in terms of android device, it is not properly validated in terms of ios device, then there can be a vulnerability, and user privacy is at a stake. Maybe that device is required thumbprint, means the biometric lock, or user profile to be synced, or email to be synced, then username and passwords are there. If that application is again connected to a banking application, then that credentials will be there. So because of that uncertainty and the poor privacy protection, your application can be vulnerable, or it can be at the site of the vulnerability and can be exploited, and your entire device can be hijacked through that device or through that exploited application. That is the possibility in terms of the different types of vulnerability. Now, what type of we can say uh, IoT attacks are generally happen. So there are three main vulnerabilities which can be exploited in IoT applications or IoT devices. First one is buffer overflow. Now the buffer overflow is what whatever the application you have built or the device you have built, whatever the coding you have done in that device, that is not having a proper uh, what we can say memory allocation scheme, and because of the poor memory allocation schema, that device can be routed against the delivery of the memory, and the buffer overflow can be happened and can be a critical condition for the developer. Maybe your application is getting hijacked through buffer overflow, or maybe your device is getting picked up by the buffer overflow attack, and that entire connection or entire visibility of that particular attack is considered, an entire device can be hijacked. Then there is a code injection and cross-site scripting. Again, it is totally depending upon if we are not following the secure code practices, secure SDLC practices. There are some protocols available. There are some security events are available that needs to be patched every time. Your sanitization of your code needs to be done. Now, what is the sanitization of a code? Sanitization of a code means when you are having any loop, we are having any function that needs to be closed properly, that need not to handle like unparameterized queries there or parameterized queries hanging there. So that is not the appropriate way to code your programs or to code your application. So that we need to consider. Now, the biggest reason of getting device hijacked is the malware attack. Now, once we talk about the malware, so what exactly malware is? Malware is a collective term for a different types of security breaches. So it can be through virus, it can be through worm, it can be a Trojan, it can be a spyware, then it can be a blended threat, remote access, adware, exploitation kit, anything which is developed for disturbing your ongoing activity, or which is developed to hijack your connection, that comes under a malware. So we need to see that whenever we are deploying our device bed or a sensor bed on a censored network or on a cloud network, we need to see that adequate malware protection is already availed on that cloud platform, or adequate intrusion detection system we have in place, or and along with that our coding is that much secure to prevent these kind of attacks. So these things we need to remember. And there are then password attacks, man in the middle attacks, spoofing attack, and boot botnet in solving, that is the DOS attack, remote access attack, data leakage. Then there are a lot of other attacks which are there and possible on an IoT device. So what you can do to improve your Internet of Things security? First thing is change your default passwords. So that is the most required thing. So once you are having any device which is having a dashboard kind of a login, just go and change its default user ID and password if you are an administrator. Then as much as possible update the latest software. So if you are having any kind of a router or the gateway or any networking device on a cloud, then do update their firmware. Now we will be asking that device is there on the data center, how will we go and update it? There is a question answer sessions, or not the session, sorry, there is a question answer section on each cloud service provider or technical reach to all cloud service providers. There you can make a query that you need to update this kind of instrument on the latest one. If you're using Amazon or Azure, they are updating their devices regularly. But if you are using any third party application, then you need to consider it, or the application you have developed, then you need to contact your developer or your technical team for doing the possible updates. Even the program what you have written, if they required any supportive library, that also needs to be updated regularly. Then as much as you can use the two-factor authentication, like we seen in IAM, identity and access management. Two-factor authentication at least needs to be there. Then we need to identify any physical weakness in your devices. So the node MCU is having a biggest threat to brick, as if the DDoS attack is happening on the node MCU's access point network, then automatically or in a few minutes that node MCU is getting busted. So we need to see this kind of a weakness in IoT devices, and we need to patch them, or we need to do some kind of research to avoid these kind of activity. Then we can have other network, which is create a secondary network on the IoT device, means the redundancy we need to have. So if one network fails down, then another will take up, and your show will go on. Then now another part will be secure your home Wi-Fi. So of course, if you are having internet connected devices to your Wi-Fi, then you need to secure your Wi-Fi router first and then your devices. Otherwise, your devices are secured, but your router is not. So ultimately, all the information is going through that router and coming in through that router only. So if I manage to hijack router, then game is over. Then disconnect the device from the internet when it is not in use. Read the device manual for a security. Download security application. Means the antivirus, at least if your device is having a proper Raspberry OS or kind of, and use a proper hardware solution to secure your IoT network from outside attack. So we need to have IDS or IPS kind of a application to secure your IoT appliances. Right. So these are the basic security guidelines, and these are a very basic security guideline which we can possibly take for securing our IoT infrastructure. Now, as I said before, in the morning session, we will be taking up a one use case where the NFC card can be read, right? So what I'll do is I'll demonstrate that demonstration for today, and after the demonstration, we will be done for the today's session, and then we'll continue our talk in next session. So give me a 2 minutes only. I'll just page my fetch my devices, not the node MCU, the NFC card, and Uno will require for it. So the Arduino Uno. Give me a 2 minutes only. I'm set. Just open up my camera. Okay, so here it is. Show it like this. Okay, show it. So this is the RFID RC522 RFID read and writer module. So this can read and write RFID module. So I'm having a RFID card, a blank RFID card, which is not actually the RFID card. This is the NFC card. And then here I'm having my debit card, which is having a NFC chip inside, and this is a functioning debit card. So that's why I'm holding like this, so you cannot see the numbers or the card number. Okay, and one more NFC reader I'm having over here. So this is the advanced NFC reader than this. Depending upon the encryption, what this NFC cards are having, so we need to select the NFC card readers. So out there in the market, there are 4 or 5 types of the NFC card reader, but these two are good for reading out good quality of the secured material. So here on the card, it is having a very good security, but still we'll just check whether we can read the data or not. Now I'll be not demonstrating the entire data what is there in my card, because it can be my security breach. Because on the card, it can have a sensor ID, it can have a card ID, identification number, NFC identification number, and all the data. So instead of that, what I'll do is I'll just bring up a SAC ID. So SAC ID is responsible for communicating on the network. So I'll be just taking up the SAC ID, and then I'll demonstrate it. So for this, we need to interface this with Arduino Uno or any Arduino development board. Even Raspberry Pi will work with this. So allow me at 4 or 5 minutes to interface this, because it is having a lot more cables to do. For this, again, will require male female cables. So I'll just bring up all the cables. So for this, I'll be borrowing the self-coded code from its library itself. So I have already inserted RC522 library. So from there, we'll borrow one sample code. Here it is, RC522. We'll borrow a sample code like dump info. So it will dump the information out from my debit card. Even I can have a read, write, default keys, cloner. So here you can see RFID clone. So I can clone that card on my empty card, and I can use. So this can be a very good schemer, but only the thing is you need to be very close to the person's wallet or pocket to clone the card. Now what I'll do is I'll just take the dump info uh, example, and here is the pinout for it. I'm using Arduino Uno. So here is the reset pin, SDA pin, MOSI, MOSO, and SCK pin. So they need to be go in an exact this pin order, because accordingly it is having a code. You can make the changes in it if you want. So I'll just take out the pins, 1, 2, 3, 4, 5. Okay, so I'll be having SDA. I can have SDC, MISI, MISE, ground, and two more pins as reset and VCC. They have not mentioned it, but we need to give a power. So yes, I have made the circuit over here. Accordingly, I need to interface it with Uno. Okay, first one is 3.3, and yes, this will work with the 3.3 volt. Don't give a 5 volt input, otherwise you'll destroy reader. So I'll put carefully on 3.3 set. Then I'm having reset to pin number 9, 8, 9 here. Then I'll have ground. I'll put ground anywhere. Then I'm having MISO. So MISO will go to 12, 10, 11, 12. Then MOSI to 11. SCK for 13. And finally SDA to 10. Okay, fine. So all the connection is done. Let's change our board type from Node MCU to Arduino Uno. Port to COM14, and let's upload a code. Even you can have RFID tags. That tag I misplaced somewhere. I'm not holding it up. Okay, so here if you can see on serial monitor, you need to open a bird 9600 rate. Here it is. So here we can see firmware version is 09xv2, a PIC2C VID SAC and type means what it will have unique identification number, SAK and type. So what I'll do is I'll take my debit card and I'll just hold it on the pin. We'll see what I can read. So if you can see, is my screen visible properly? So this is what the information is dumped. If you can see over here, my debit card's unique identification number is 926A471C, having a card SAC 08. So this is the SAC ID where the information of my NFC is going, or the RFID is going, because the NFC is what it is, an extended version of RFID. So some RFIDs are capable enough to read some data, not the entire data. So that's why it is showing some failed and timeout in communication, and it is having some sector blocks on it. So by this, fraudsters can create skimmer and can clone your NFC enabled card. Now, how to secure your card? Because I've shown you how to get the data, but how to secure it? You can place your card in a metal foil paper or metal case. So there are some card holders which are a metal card holder, so you can place it. So because again this required 4 to 5 centimeters range to scan your card, and again if there is metal which is blocking its RFID, then again it is secured. Or if you're not getting any metal sheet or metal card holder, then what you can do is you can get aluminum foil paper, which is again very lightweighted, and you just wrap it on your card and then place your card on your wallet. So that way you can secure yourself from being hacked by these NFC skippers. All right, then this is for the day from my side. We are open for question and answers. If you are having any questions, any suggestions to add, please do ask, and please do tell. Okay, so I guess there are no questions from participant side. If you do have, please post it in WhatsApp group. I'll answer them. And this is from my side for a day. Thank you very much. See you on tomorrow for another session. Thank you.